Hello, everyone. I'm Petr Špaček, working with CZC, ISC, sorry. It's getting complicated over the years. Anyway, I wanted to say that this is a joint work with Victoria Risk. She couldn't be here, but it's definitely a joint work. And also, I have to thank wonderful chairs we've got because they allowed us to run sort of an experiment, because we started with a survey among the members of this working group and also in other places. And at the first part of this talk, we will present the results of the survey. Then we will compare the results of the survey with whatever we've got in practice in Bind9 DNS server. And then hopefully we will have some time for discussion. So thank you, chairs, and also thank you for helping me to run the survey, because you were instrumental to getting the answers. So, survey. All the details or the statistics for the survey can be found on this wonderful URL. We will have just a short version here for the sake of time, but you can read all the data over on the internet. So, survey. It started with a difficult question: what makes a project trustworthy? Because here we were asking very specifically about the mission-critical applications, in a sense that it's like not a random, Joe's Hello World application, but something you need to run your business. And if you are selecting software for mission-critical application, what's the top priority? What you consider as the most important factors when you decide to use that project? That was the first question. And then we went on to like, how do you deploy and how you verify and so on and so on. So, second important aspect of the survey is that it wasn't a random Facebook poll or something. It was sent only to basically an expert mailing list. And in these places, we would expect expert users, not again random Joe asking about random stuff. So if someone just installs a package from the Linux distribution and copy-paste this configuration file from some how-to, that person is unlikely to participate in those mailing lists. So the assumption is that more or less we get like experts answering about the mission-critical software. And over the period of 1 week, we've got 71 answers, like valid answers, like non-empty and so on. And second thing is that because of the selection of the mailing list and the channels we use to reach the experts, the answers were very heavily biased towards the DNS software. Approximately 2/3 of the answers were about the mission-critical DNS software. But the good news is that when I compared answers for DNS and non-DNS as two groups and looked at the charts, the answers are mostly the same. The non-DNS people think more or less in the same terms as the DNS people. So here we will present it together as one group. Okay, back to the hard question. If you are selecting software for mission-critical application, how do you decide? What are 5 most important factors you consider most important when you are selecting the project? To my surprise, I have to say, we've got these 5 top answers. So documentation in the first place, quite clearly, and active and kind of helpful community, we can say. Also, the way how the project releases and maintains the versions. And also on the 4th place, the familiarity with the software, which kind of shouldn't be probably a surprise, because if you are familiar with the software and using it for some time, you kind of gain the confidence over time. So if you know some software and you decide for another deployment, you might very likely use something you already know. To my surprise, I have to say, on the last, on 8th place on this slide, on the last stand, there was a history of CVEs. So apparently the history of the security issues in the product over its history is not the main factor, or at least it's not among the main 5 most important factors. On the second slide is the rest of the options we offered in the multiple choice section. I will not read all of them, but you can see that these are even less important than the history of CVEs. We will get to some of them in more detail later on. Okay, so now we've selected our project, what software to use. Of course, supposedly we should be verifying the signatures before we do anything with it. So we've asked people, how do you verify what you've got? Half of the people said that we are relying on the package manager to do its job and verify the signatures. And then approximately a quarter of people go through all the trouble of actually verifying that the PGP, Web of Trust, and everything matches what it should. Now we have the source code, downloaded, verified, we can have a look or not. It turns out that 3/4 of the people don't really look at the code at all. And approximately a quarter of people looks at the code in some way, and that doesn't mean reading all of it, but sometimes the people, for example, read the release notes and then diff the new version and the old version and have a look at the changes between the notes in the documentation and the changes in code, something like that. Of course, now we have the code. The question is, how do you install it? And next, basically kind of matches what we saw in the previous answers. Half of the people install packages from the operating system. Another quarter approximately installs the binary packages from some source. And like above, around 18% installs from the source code. Next question is, okay, you finally installed your software, but eventually you need to upgrade it. And as we know, on every upgrade, something can break. The question was, what do you do? How do you mitigate the risk that it will blow up after the upgrade? And it's quite nice to see that approximately 2/3 of respondents said that they have an ability to do rollback very easily. So they are not, super concerned. That's nice. I would like to have it on 100%, but 2/3 is not bad. And then half of respondents said that they do their own tests before deploying. That's also good, I would say. Again, all the details are in the URL in slides. We don't have time to read all of it. And now we are getting to the question, okay, how do you test before production? Again, half of the people indicated that basically they don't, because so far, so good. And I think that's also interesting because it tells us that the quality of the random software you find on the internet is not so bad because it doesn't explode every time you upgrade. So half of the people don't feel the need to actually run the test before upgrading because apparently it's working so far. And then you can read for yourself that the other half of people test the software in some way, and just around 10% of respondents bother to actually run the unit tests included in the software. Maybe because the developers are supposed to actually do that, so why would they run it again? It makes sense. With that, we've done with the survey. That's just a brief overview. And now we will fly through the Bind 9 DNS project, and that will serve as a comparison, like reality check, what the survey says and what the project does. And that will be more interesting than I expected when I promised the topic. Quick recap, not sure how many DNS people we have in the room, but Bind version 9 is 26 years old code base. So that's really a project with some history. It has over 250,000 lines of C, excluding tests, excluding comments and whitespace and so on. Complicated build system, over 50 people contributed, and still have at least one line in the Git today. Ridiculously complicated configuration, don't get me started on that. And also, over the years, it gathered on average 5 security issues, or like 5 CVs assigned on average every year throughout its history, which might be good because the people apparently don't care that much. Yeah, so the question is, I want to use a DNS server for my critical application, and this is a super large, super old code base. How can I trust it? And the answer is basically you can't, because there is no way for anyone to read all the code. And we at ISC were thinking that, well, we know the code, but there are dark corners, and we would have better feeling if we had someone else externally reading the code and seeing what's hiding in there. But maybe we have like blind spots and not see stuff. So we've contracted auditing firm, which previously worked on Unbound resolver projects, so they had some exposure to DNS before. You can read all the details in the blog post listed from slides. But anyway, after a couple months of work, they found lots of things of various severity. One of them raise to the level of actual CVE and all the circus around it. But there was lots of low-level bugs, like, for example, integer overflow, because bind is in C, so it's easy to make bugs like that. So we are kind of happy that they didn't find, like, glaring hole, except that it turned out that the audit has its limits, because these auditors were focusing on the low-level things, the usage of the C language, how it interacts with the operating system, and so on. But while the audit was running, we've got 7 CVEs for bind. Some of them are not bind specific because they're like generic problem in the DNS protocol or the NSSEC protocol, but some of them are bind specific. And the difference is that the auditors were focusing on low-level usage of the language and the machine, but all these bugs on the slide were actually high-level problems in a sense that some sort of limit on resource consumption was missing, or there was a logic bug which allowed the attacker to crash the server, or things like that. Maybe a good news for the bind project is that apparently people don't consider this kind of problem to be top priority in the top 5. So that's the comparison with the survey. You see, like, 1/4 of people consider CVEs the most important, one of the most important factors. So maybe that's why people still don't use bind. Anyway, of course, inspecting the old code or doing audits, that's kind of post-fact exercise, right? You already have the code done, but we would like to not introduce the bugs at all, preferably. So we have coding standards, how we are supposed to make new features, so how we are supposed to make modifications, and also like review procedures, what you are supposed to check, and lots and lots and lots of other non-technical requirements, which are kind of self-imposed. I will not go to the details because it might be boring for technical people here, but if you're interested, you can have a look at the slides. There are these links. The blue text is clickable, and the Open Source Software Foundation Software Quality Badge will lead you to a document which lists like various non-technical things which the Open Source Software Foundation considers important for quality of the project. And yeah, of course, again, security issues. We have like policy, how you handle them, how we score them, and so on and so on. In short, it's a ton of work which is totally invisible for anyone not working in the core team, because if you open the source repository, you will not see a commit saying, well, we spent a week analyzing the CVE, or because it's not visible in the code, but it's a lot of work. And funnily enough, according to the survey, it's again something people don't really care about, because according to the survey, only 11% of respondents consider the way how the software is developed an important factor when selecting the project. That was kind of eye-opening for me. And yeah, just briefly, as in an attempt to prevent bugs from entering the code base, we do a code review, and bind is kind of specific in a sense that we don't really get external contributions. It's very few external contributions over the time, and they are usually very small. So in essence, it's one core developer reviewing work of the other core developer, and it's like literally peer review. Of course, we have a bunch of automated tests because humans are not really good at catching some types of bugs, and performance tests and whatnot on site. We kind of take pride in our test coverage, and the project literally has like 12,000 assertions in an attempt to find a logic bug. So if something unexpected happens in the code base, it will supposedly hit an assertion and crash the server, which is obviously a denial of service attack. But this was thought as a trade-off, that we rather crash the server instead of allowing the unexpected state to propagate throughout the system and possibly corrupt the data or exfiltrate keys or whatever. So this is, again, a debatable decision of the project, let's put it that way. Continuous integration, nowadays everyone has that. The trouble is that it doesn't fit on slide, but basically it runs all the tests we have on multiple architectures to catch architecture-specific and distribution-specific bugs. They still happen nowadays, like broken P threads on certain version of Ubuntu or crazy things like that. And again, it turns out that we go through a lot of trouble and users don't care. Because according to the survey, only 13% of users consider the project's test suite and the coverage as an important factor when deciding whether the project is like worth using for a critical application. Yeah, peer review. I mean, what can I say? Someone has to read the code. In more practical terms, it means that someone goes to GitLab, reads the code, and then once the reviewer is satisfied, he clicks the button approve, and that's seal of approval, good to go, and then we release. Yeah. 3 years ago, we went through all these checks and reviews and release process just to find out that a couple hours after releasing the new version, someone complained that it's kind of broken in sort of weird way. And then we found out that we just forgot the W in the conversion table. And the automated test didn't catch it because it manifested itself only in weird, well, not weird, but like combination of factors which was not covered in the test suite. It had to be capital W, it had to be DNS wildcard at the same time. And we have tests for wildcards, of course, but they didn't have that specific combination. So that, again, an illustration of limits of the automated testing. And the peer review kind of also has its own limits because, yeah, of course, developers like to read the code and think about like the weird corner cases, but very rarely anyone bothers to read all the tables. And yeah, I mean, it's square, it must be fine. But the trouble is that the English alphabet has 26 characters, and making square out of 26 is kind of improbable. So after fixing that bug, we had to, respin the release to new version, basically throw away the old version number, well, new and now old version number, and start over. And in case of bind, that's like intricate process, which makes me crazy every time I have to do it. But it boils down to something like sanity check what we are going to release, write docs. At least that's something which is on the first place in the survey. So first thing we are actually doing and user care about. Then run the test no one cares about again. Generate the tarball, we will talk about that, and the packages and so on. I think that the most interesting part of the release process is tarball reproducibility. Funnily enough, we've seen in the XZ project compromise that the tarball not necessarily matches what's inside the Git repository. And again, I'm kind of proud that we thought about that problem before it became publicly known. So we have a script which takes the Git repository or tag, the specific tag from the repository and the tarball and does cross-check whether it matches or not. So before we sign the release, we check that the tarball actually matches what's in Git, and then of course we can check it again. It has 100 lines, so anyone can go and actually see it because check it with naked eyes because the 100 lines includes Docker file, so basically a list of packages you need. So it's not really hard to check. So I find it interesting. And then signing, of course. We don't want to sign random malware with our signing keys. And we don't want anyone stealing the key and signing it without us knowing. So the signing key is, every person has its own Ubico, like hardware token with a key inside. The key is not exportable. And if you want to make a signature, you have to press the button so you know that you've actually made the signature. So that's another like layer of defense against like signing something we don't want to sign. Yeah, but again, it's a lot of trouble to go through, but no one really cares. Well, not no one. Let me correct myself. It's like 1/4 of people actually care about these like signatures made through this complicated process. And packages, that's again a lot of unthankful work. We do them for RPM, for Debian, you name it. But again, there's kind of slight disconnect with the reality because we spend some energy on it, but less than 1/3 of users actually care about the binary packages produced by us because half of the users takes binary packages from the operating system, and we have no influence over that. Yeah. So this is the last slide I have. And it's kind of summarizing what we've seen in the survey and what we do in the Bind DNS project in particular. And for me, it's kind of disturbing to see that we invest really a lot of energy to like processes around like security issues and how we review stuff and how we test stuff. But according to the survey, if we are going to believe it, it's not anywhere close to the top priority, because basically the top 5 priorities were all non-technical. These were like documentation, community, release cadence, and so on. But all these top priorities were non-technical. And I see strong disconnect between what we do and what the survey says. Now the question is, for example, is this because all the users like kind of implicitly assume that the projects do that? So we have to keep doing that, even though the survey doesn't indicate it, or is it something else? And hopefully we will have time for discussion, because this is end of the slides I have. And I very much hope that you will express your opinions on what you are expecting the projects to do, like kind of implicitly, and don't even say that aloud in the survey. Or are we insane and should we stop doing the circus around CVEs, or you name it.
Okay, thank you. So the queue is open. We have quite a bit of time left, so bring up your questions.
Hi, Alexei Samorukov. Let me speak as FreeBSD committer and SmartMon Tools committer. I think there is kind of here misunderstanding. Do my users really care if I'm doing unit tests? No, they don't, because they want tool to be up and running. Do I care as developer? Of course, because when I want to do a refactoring, there is a very little chances that unit test will pass until I will fix all the places where this old way of old coding convention were used, right? So this query doesn't, this questionnaire doesn't mean that you're doing something wrong. It just means that your target audience don't really care. Same as you mentioned about unit test. Do I want a consumer to run unit test? Of course not. Why? Why I should spend time and energy on it? Yeah, maybe a few suggestions about basically packaging an operating system. What to me is a huge pain, especially Debian, who, yeah, they like to do own patches. If upstream is cooperating with major operating system, to me it sounds more important and more productive than when you're just publishing RPM repositories or deb repositories on your website. Because yes, nobody would use them usually. It can cause all kind of troubles. But if you're working with upstream and ensure that patches they're adding make sense, that versions they're using make sense, etc., it helps a lot. And the last point probably is about CVE. I think it's a different kind of help, but I think situation is fundamentally broken here. Last time I see that most of the CVEs are either with high or critical rating. This was recently pointed out by Curl after, where they brought some absolutely minor issues as critical and high, and he spent basically months to lower these priorities. And to me, the situation is kind of really strange. You're putting a lot of energy, then you're getting this crap in the databases. You're spending even more energy to it, and yeah, I don't know what to do really.
Thank you.
Marcos Sanz here from DKIX. Thank you very much, Peter. First for organizing the survey, which I think it was a great thing. I participated also myself, and I enjoyed. We shouldn't draw the wrong conclusions here, looking at this table. It's not that because people put the automated tests in priority 11, you should stop doing it. That'd be the wrong conclusion. I'm not going to run your unit test because I don't expect you to deliver something which does not pass the unit test. I'm not reviewing your code because I expect that you have a process where people review code. So we're in a kind of a complementary situation where you do some things and I do some things, and you're the expert on your side and I'm the expert on my side. So Yeah, I think you're doing it right. I'm very happy that you display openly about the ISC process you are using for bind, and yeah, keep up with a good work.
Okay, if I can clarifying question to your question or comment, does that mean that basically this survey question says, or do you interpret it in a way that this is like about the user visible stuff? I mean, because it mixed, this question specifically mixed like documentation and the things user daily interact with, and also like the behind the scenes things like the development process and so on. So do you think that it means that the top priority for users is top priority because they do it every day and they just don't like even think about the development process? Is that what you are saying?
That's a very nice way of putting it. I haven't thought of that myself, but yeah, I think there's some truth to it.
Yeah, okay, thanks.
Jim Reed speaking for myself. So nobody else. Yeah. Marcus summed up the situation fairly well and said one or two of the things that I wanted to say. In terms of doing testing or evaluation of, say, bind 9 releases, I don't bother, quite frankly, because I trust that the ISC, who's got a great pool of fairly talented, clever engineers, I know they're going to turn out code which most of the time is in an excellent shape. We'll get the occasional bug here and there, but so what? There's always bugs in software. So I don't need to do code reviews or anything like that, or any kind of own personal regression tests. And always know I can hunt you down at an ITF meeting or a right meeting if there ever a problem arises. So I don't need to bother checking. And I think many other people in the room will probably have a similar approach to that. Where I think the problem lies, in my view, is not so much with the software that you're producing, is what people then do with it later. And I'm thinking particularly about the people who are distributing packages for various other open source operating systems. And I suspect the level of quality assurance and testing that they do maybe isn't all that great. And they may all be doing the same thing as I do. So, oh, this is the latest release of my ISC. They've tested it. I don't need to worry anymore. So I don't need to have any kind of regression testing or QA of my own before I throw it over the wall into the public distributions. So I think that might be something for you and your colleagues to look at, is have a conversation with these people to see what kind of testing they do and how well it matches up with what you're doing. I think another problem we've got here is not so much with the software itself, Peter, but it's with the ancillary stuff that you rely upon. I'm thinking particularly of OpenSSL. So you've got all the problems that then creates, which are outside your control, but you're kind of constrained because you need to use that crypto library for all these other kind of things. And we get situations like we saw before, long ago with OpenSSL, with the Heartbleed thing about 10, 15 years ago. And then we recently saw something similar with the XZ compression stuff. Okay, it didn't affect bind, but it's an indication of the problem we have generically in the open source world, because the amount of testing that might be done by someone who's producing the software may not be all that great. Some of these packages are got one person working on it in their spare time, so they're constrained with what they can do from their own resources. Then, of course, nobody's really checking or looking over that stuff before they throw it over the wall into a release. So that's another part of the problem. And the final point I wanted to make is, this is a great presentation, and I've loved everything you've had to say here, Peter. It would be great if you could write this up and put it up as a blog posting on the IC. This is how we test and do QA on our releases before they get shipped. I think that'd be a wonderful thing to do, and it may also encourage others to do the same thing. Thanks.
Okay, yeah. Thank you for the idea. I think that I will need to buy flowers to stenographers because that might be saving me tons of work. Thank you very much.
Okay.
Moin is speaking with my previous decommitter hat. So what happens is you're actually developing an open source application, but think about the users of it, like who are actually using it. Those are actually mostly sysadmins or network admins who actually are mainly concerned about the operation of the application rather than the internals of the application. And for them, definitely documentation is much more necessary compared to other things. They do not need to go through the CI process, the continuous testing process, and anything else. So definitely, and they do not actually, definitely they care about the upcoming CVEs or is there anything in the mailing list compared to what happened a couple of years ago, because the software development paradigm has actually shifted a lot within the last 10, 15 years in terms of security. Thank you.
Thank you.
Okay, thank you. We have a question.
Yeah, Willem Torop in LN Labs. I just wanted to say thank you to ISC actually for doing this work, because it will also be very beneficial for us as a software vendor. And it's really very valuable for not only makers of open software, but also the users, because they will benefit by this as well. So thanks. Excellent work.
Thank you. I'm starting to blush. Stop it.
Thank you.
Yeah, +1 for that. I think you've done a great job. So keep it up. And I do think that that you running into the same problem that the car industry has, right? So people care about whether they've got the TV screen in the back to keep the kids amused, because everybody's figured out how the seatbelts work and nobody tends to worry about that. So with the exception of the Volvo drivers, nobody seems to ask about. They assume that you've taken care of the security problem. So
okay, that makes sense. Yeah.
So, but just keep up making sure that the seatbelts work.
That also makes sense. Thank you.
So just quick reminder, please state your name and affiliation when you come off the microphone.
If I can.
No more questions then. Thank you very much for your presentation.
Is this still valid? I would like to, yeah, okay. I would like to kick out one more discussion point if we have the time, if it's okay. Thank you. Someone, I forgot who, sorry, maybe Jim, mentioned that the trouble might be the distribution, because we produce a tarball, then the tarball gets included in Debian, Ubuntu, you name it, and then some distributions decide that, okay, we are not going to change the tarball ever again during the lifetime of the particular distribution. But the question is, can we, or what do you think about the model where the distribution is applying hand-selected patches to the tarball as opposed to upgrading to the new, minor version of that same software? Because different people have different opinion on that. There's the school of thought which says, okay, if you hand-pick the patches and apply them one by one, you get like better quality software, because over time all the bugs are essential, or the important bugs are essentially fixed, and you have like stable version which is, cannot possibly introduce breaking change because you are not upgrading really to. Or the second school of thought is, well, if you apply a patch, you just created a new unique version, so it's just you running that unique version with the patch, but the rest of the community is running something a little bit different. So now you might have new security issue because you've missed one of these important patches or something. And if we have reportedly a couple minutes for discussions, I would like to hear opinions on that, what people think, and if you agree or disagree, what's your distribution doing, and whether you see a way how to influence what the distributions do, or whether what they are doing, like Debian and Ubuntu and Red Hat and so on, is okay and they should keep doing that. I would like to have some discussion if we have still time for it.
Okay.
Yeah, maybe I would like to start. So first of all, as SmartMon Tools developer, I really hate this practice, because we constantly, every month in our mail list, getting reports from some modern operating system which using some ancient version of SmartMon Tools. And in fact, it's not even this ancient version, it's strange golem, because they applied some of the patches, some of they forgot. Also, developer knows better than I am a core developer for 20 years of this project, what he needs to apply. So don't do it. And also, I think it was making kind of sense when we were living in world of Red Hat 6 and very, very stable operating system, which everyone was afraid to touch, right? Now we are living in containers world where things are super dynamic, where you can easily upgrade, downgrade using Git flow many times per day. You can release often, you can release quickly. You don't need to do it anymore. So one of the things which is kind of edge case and exception is patches specific for distribution, and typically they are very small, like init scripts, and I'm perfectly fine with this. Only thing which is really, I feel cool, BrewSH in Mac have a very good practice. If you want to apply any patch, shows that you try to upstream it, and shows that as a vendor told that this patch doesn't make a sense to be in the project, it needs to be outside, or he accepted it, but it's not yet released. Then you can apply it. I think it's the best way to handle it.
That's an interesting approach. Thank you for that comment.
Andre, Debian developer since 1999. So I think it's a fallacy to think that it helps to keep a stable software with patches. Of course, it creates some kind of problems. Things could break if you upgrade to the latest minor version. But for the complex software, it's a fallacy that it helps. So for stuff I maintain in Debian, and that's PHP and bind, I actually made a deal with the release team and the security team that we push the latest minor versions to Debian. Ubuntu doesn't do that, and we see that it creates problems with complex software. It is a problematic for stuff like bind or PHP or anything that's more complex than, I don't know, the Fortune program.
Yeah. If I'm correct, Firefox basically, or web browsers are being upgraded in all the distributions, right?
Yeah,
There's no distribution which patches Firefox.
Yeah, I think so.
Yeah.
Maria Bird-Cizinik, we are doing the same with Bird. We are pushing the maintainers in the distributions. If they even try to put there some patches to actually upstream them, we are actively trying to pull those patches from the distributions and integrate them, or convince those maintainers to actually remove those patches because these patches are bonkers. And it sometimes works, and sometimes we get just angry with them and it doesn't work. And I very must agree very much with all those who say that now the software is complex, and applying random patches is just a no-go. It may kill the whole performance. It may add other security overhauls. It's just a whole mess.
Okay, we close the queue after Shane. So Shane, you're the last one.
Okay, well, I won't promise anything. Shane Kerr, IBM. So my understanding is that there are organizations that have policies about version numbers that are very strict, which is probably encouraged by enterprise Linux, for example, where you have versions which don't change for 13 years or something insane like that. And I know people working within these organizations don't care. They literally wouldn't care if you patched a third of the program as long as you kept the patch release version the same, right? It's the number that counts, because that's what their senior vice president of keeping things the same is going to insist on. So I guess the question is what to do about this. Like, if I'm an engineer working in some huge telco that has this policy, I have literally no power to change this. I can complain to my boss and they can complain to their boss, but probably it's not going to get changed. So as an open source community, what's the best thing? Now, one approach is the sort of accelerationism approach, where we're just going to do, like you were saying, like run the Docker things, keep things dynamic. And if you're in a company that refuses to upgrade versions, you're going to end up with insecure, buggy stuff. And we just say, let those companies burn. I don't know if that's the right approach or not, but I don't really know any other approach other than to just sort of keep letting people backport patches and having to deal with support. So I don't know if there's a good solution here. Maybe it's something that maybe people smarter than me have a good suggestions here, but yeah, that's it.
Okay, so maybe if we have our own packages, which always have the same version number and change only, the number after the dash, but in fact it's like a new version. Yeah, whatever. I'm joking. Sorry.
Well, you're joking, but like if you put up a web page which said, this is exactly the same as this other one, but we preserve the version number for you so you can convince your boss it's okay. Like, I don't know.
Okay, thank you very much.
Thank you.